Lesson 7.4 is on the multiplication properties of exponents, and because we've done work in class to prepare for this lesson, this should go really quickly. Now in your book you're going to find a definition. Today in class what we talked about was the fact that x to the third raised to the fourth power meant that x to the third was being multiplied by itself 4 times, just like this. And I had you write it all out. What the book gives you is a rule or a shortcut, and that rule is whenever you raise a power to another power, you can multiply those two together to get 12, which is x to the 12th, which is the same thing that you get when you multiply x to the third by itself 4 times. So let's take a look at some problems that involve this shortcut. Here's the first problem. Instead of writing out all that work, what you should notice is p to the fifth is being raised to the fourth. So that really means p to the fifth times 4, or 5 times 4, which is p to the 20th. In the second one, p to the fourth is being raised to the fifth. It's essentially the same problem. 4 times 5 is still p to the 20th. But where this shortcut helps you is when you start dealing with negative exponents. So in part C, p to the negative fifth raised to the fourth, negative 5 times 4 is p to the negative 20th. And to simplify that, you just have to move it to get rid of the negative exponent. So it becomes 1 over p to the positive 20th. Fairly straightforward. Now the rule also applies when you have exponents that are being multiplied and then an additional part, like the example I gave you in class. So the only difference between these problems and the problems we just did is only a part of this problem has a power raised to a power, and then it's being multiplied by an additional exponential number. So it's like a two-step problem. So x to the sixth raised to the negative fourth is x to the 6 times negative 4 is negative 24. And that's being multiplied by x to the second power. When you multiply like bases, you add the exponents. So 2 plus negative 24 is negative 22. And again, you simplify it by moving the exponential number from the top to the bottom to make it positive. So it's x, or 1 over x to the 22nd. So very similar in part B. W to the 7th raised to the third power. You multiply 7 times 3 to get w to the 21st. And that's being multiplied by w to the negative second. Negative 2 plus 21 is 19. So it's w to the 19th power. And I'll keep going. R to the negative fifth raised to the negative second is r to the positive 10th times r to the third. 10 plus 3 is 13. So hopefully if you've done the work from class today, you understand where these answers are coming from, but you get them much quicker by using this shortcut. Okay, now when you raise a product, when you have numbers inside of a set of parentheses that are being raised to an exponent, it's slightly different, and it's almost like the distributive property. So you can almost think of it, but it's not quite the distributive property, but you can almost think of it like this. If I have a product, which is two numbers being multiplied together, and that's being raised to a power, you're going to give the exponent to each part of the multiplication inside. So you're going to give the 2 to the x, and you're going to give the 2 to the y. This becomes x squared, y squared. So here are some examples. In this first problem, 7m to the 9th power is being raised to the third power. Now if I write it all out, which I'm not going to, but it would be 7m to the 9th, 7m to the 9th, 7m to the 9th. Instead, what I'm going to do is give the 3 to the 7 and give the 3 to the m to the 9th, and it looks like this. 7 to the third power and m to the 9th to the third power. M to the 9th raised to the third power. 9 times 3 is 27, so it's m to the 27th power. 7 to the third power is 343. And that's the answer. If I do that in part B with a negative exponent, I'm going to give the negative 4 exponent to the 2 and to the z, so I get 2 to the negative 4th, z to the negative 4th. Both of these exponents are negative, so I'm going to move both of them to the bottom and make it 1 over 2 to the positive 4th and z to the 4th. And you can go one step further. 2 to the 4th is 16. 2 times 2 times 2 times 2. So your answer is 1 over 16z to the 4th. And the last example, negative 2 is the exponent on the outside, so I'm going to give it to the 3 and to the g to the 4th. So I write it out. 3 raised to the negative second, g to the 4th raised to the negative second. G to the 4th raised to the negative second becomes g to the negative 8th. These are negative exponents, so I can move them down below the fraction and make them positive. So it's 1 over g to the negative 8 becomes g to the positive 8. And at the same time, as I move it, I'm going to calculate what 3 to the second is. It's 9. So 1 over 9 g to the 8th. Okay, problem 4 is a combination of everything that you've done so far. We're going to have some powers raised. Some of them are a power of a power, some of them are a product of a power, and you're going to multiply all of them together. This is where things happen where people start to get a little freaky. So if you just take it slow and one step at a time, calculate, you should be fine. So I'm going to look at the first part. X to the negative 2 raised to the second. 2 times negative 2 is negative 4, so that's x to the negative 4th. The second part, I'm going to take the outside exponent and I'm going to give it to each piece inside. So it's 3 to the 4th, x to the 4th, and y to the 5th raised to the 4th. Now some of you like to take shortcuts and do a whole bunch of this stuff in your head, and that's great if you can do it, but what happens is people who take shortcuts and really don't know how to take the shortcuts end up getting them wrong. So if you take 2 extra steps and get the answer right, that's way better than taking shortcuts and getting it wrong. So I'm going to show you each step the way I would do it. Y to the 5th raised to the 4th is y to the 20th. This is x to the 4th. 3 to the 4th power is 3 times 3 is 9, times 3 is 27, times 3 is 81. When you have an expression that has letters and numbers, the numbers always go first. So I'm going to write the 3 to the 4th power, which is 81, out front, and write this x to the 4th right here. And what you should notice is x to the negative 4th times x to the positive 4th. When I multiply these, negative 4 plus 4 is 0. X to the 0 is just 1. So my answer is 81 y to the 20th. I'll keep going. Part B, 3c to the 5th raised to the 4th, c squared raised to the 3rd. Again, I'm going to go a couple extra steps that you should write out also. 3 to the 4th, c to the 5th raised to the 4th. That's this first part. And then c to the 2nd to the 3rd is just c to the 6th. c to the 5th raised to the 4th is c to the 20th times c to the 6th. 3 to the 4th, as we already saw in this last example, is 81. Just one step left. C to the 20th times c to the 6th is c to the 26th. So your answer is 81 c to the 26th. And the last one. Give the 3 to each part inside. That's 6 to the 3rd, a to the 3rd, b to the 3rd. And the second part, give the 2 to each part inside. So that's 5 to the 2nd, a to the negative 3, raised to the 2nd. 6 to the 3rd power. 6 times 6 is 36. 36 times 6 is 216. 216, a to the third, b to the third. 5 to the second power is 25, and a to the negative 3 to the second power is a to the negative 6th. So I have two numbers in this problem, 216 times 25. I'm going to write the answer to that out front. A to the third times a to the negative 6th is a to the negative third, and b to the third. (216) times 25 is 5,400. The only thing left to do is take this a to the negative third because it has a negative exponent and move it down. So my answer is 5,400 b to the third all over a to the third. And that's pretty much it. There are two other types of problems that you're going to see in your assignment, so let me take a quick second and show you those, and then I'll be done. And here they are. You've been working with scientific notation numbers. You can also raise a scientific notation number to a power. Now the thing you have to remember is this little x in here just means multiply. So it's really 4 times 10 to the 5th raised to the second power. And what you've learned is this 2 on the outside, when you have a product in the inside, just gets given to each piece. So it's 4 to the second times 10 to the 5th to the second. 4 to the second is 16 times 10 to the 5th to the second is 10 to the 10th. Now depending on the problem, you may be okay to leave it like that, but usually it will say write it in scientific notation. So 16 written in scientific notation is 1.6 times 10 to the first power times 10 to the 10th, which is 1.6 times 10 to the 1 plus 10 is 11. Now you may want to try this next one before I do it, so if you are, you can hit pause now. Otherwise I'm going to continue. 2 times 10 to the negative third raised to the 5th power, I'm just going to give the 5 as an exponent to each piece inside, so it's 2 to the 5th times 10 to the negative third to the 5th. 2 to the 5th power is 2 times 2 is 4, 8, 16, 32. Times 10 to the negative third raised to the 5th is 10 to the negative 15th. 32 is not written in scientific notation, so I can do that by moving the decimal point over one place. That makes it 3.2 times 10 to the positive first power. It's positive because 32 is a big number. Times 10 to the negative 15th. And when I add or multiply 10 to the first times 10 to the negative 15th, I add the exponents and get 10 to the negative 14th. So my answer is 3.2 times 10 to the negative 14th. And that's pretty much it for lesson 7.4. Here's your assignment if you wish to get started ahead of time. Otherwise, you'll have class time tomorrow to work on this.